Hello everyone, welcome to my YouTube channel. My name is Himanshu Singh, and in this particular video we are going to talk about the VIS-RAG's practical implementation in Google Colab, right? So I'll be giving you a walkthrough of the code which author has given, like how we can uh, download and use that model for a particular use case. So I'll walk you through that particular code and I'll let you know like how you can build it in your Colab notebook and you can run it. And yeah, so let's get started, guys. And before that, I just wanted to let you know, like, if you are not aware about the VIS-RAG, so VIS-RAG is a multi-modal technique. It's a very recent research paper came out, so which is kind of using two techniques, which one is like VIS-RAG retriever and VIS-RAG generator, right? Two parts are there. I have already created a video on top of VIS-RAG. If you want to watch out that particular video, you can click on that link and you can go ahead and watch out that basic to advance everything I have covered in that particular video itself, right? So let's get started with the code itself. So before we start with any particular uh, pipeline, we just need to install some kind of dependencies. So these three are the most important dependencies for this VIS-RAG, which is transformer, sentence piece, and decode. You already know like some transformers, which is being used for any particular model, which is based on the transformer architecture. Then sentence piece is a kind of unsupervised text tokenizer and detok tokenizer library, which is being used here, and decode is there, which will make a kind of smooth running of this particular model in the particular system itself, right? So this is the kind of dependencies which are need to be installed in your notebook. So once you start with the notebook, right, so please try to open this notebook with this runtime, right? T4 runtime. If you go here and you will click on the change runtime type, you will get T4 GPU, because you will be needing this kind of T4 GPU, with Google Colab is providing it freely on right. So you can go ahead with a particular ID, and I think there are few hours they are allocating for a particular user, right? So you'll be getting T4 access for, right? So just save it and just reconnect it, right? I'm not reconnecting it right now because I have already connected it, right? Once, and I have run all the code. So I'll just walk you through the code itself, right? So you have installed all the dependencies, and then from here itself our code starts. Like, author is giving you the weightage mean pooling. This weightage mean pooling is function is given out here. When you call this particular function, we'll be calling this function below. I'll tell you about that. So nothing is providing the hidden number of units and the attention mask, right? Let me just go there and tell you like what is these things and how it will be calculating. So right, so here we are using commission function, right, which will be making a cumulative sum of whatever the attention marks tensor would be present on top of that, right? And then multiplication would be happening with the dimensionality 1, and it will kind of apply a computer weightage pooling kind of thing, right? And then it is doing kind of unsqueezing, right? And to kind of adding one more, you can say it's a kind of adding one more dimensionality, right? Broadcasting, maybe you have heard of broadcasting in the deep learning section, right? Where we do the broadcasting to make it dimension, increase the dimension itself, right? Then using the sum itself, and it will be providing D. So you are calculating S and D, and then you are dividing it S by the D, and it will be getting the repos. Repos is nothing, it's your embedding itself. I'm going to tell you like how it is being used, right? So now define the encoding function, right? So here is always two parts, right? You know, in the architecture itself, you will be having two parts. Like, you have to encode your pages, whatever the pages you have, and then whatever the query you have, both should be encoded, right? Here, if you see, you have this query, this should be encoded. Here is your pages or documents, it should be encoded, and then similarity will be matching, right? So this is a kind of function they have given. It will be taking the text, and whatever the text you have, whatever the query you have, right? In both cases, you can give the text, you can give the images as well. So here we are just trying to find out whether it is the image. If it is an image or if it is text, according to that we are creating the input function, right? If you see here, right, this input function is given. And then if it is a kind of image itself, so it is just taking it as a lane and providing is a text, image value will be here only, right? And tokenizer, whatever the tokenizer we were using here, I am going to initialize some tokenizer and it will be used there itself, right? Then output model out input star star, it's called a kind of it's a calling method, right? Let's say input is a dictionary, right? And you are giving model and star star input like this. It will be taking text as an kind of argument, and this value of this text as an value itself, right? So key value pair will be used as an key, you can say, argument and the value of the argument itself, right? It's a kind of a calling a method, calling a dictionary itself, right? Once you get your output, it will be kind of taking the mask from that output itself, our outputs dot attention mask, and then hidden also we are taking from the output itself. It will be, there would be the last hidden state. So attention mask value you are getting from the output itself, which is which model is providing you the output, right? Outputs value from that itself you will be getting the attention marks, and also the hidden value also you'll be getting the last hidden state itself from the model itself, which is outputs, and which has been given from the model only, right? So now you got attention, you got hidden, both will be the tensors only, right? If you want to deep dive on the code, guys, just try out this code and write kind of print statement. You will be able to understand like how it is going to be happening, right? So weightage mean pooling. Here now we are calling this weightage mean pooling. We are giving hidden and attention mask, both the tensors here, and now this would be calculated and it would be creating the wrappers itself. Now this wrappers value we are giving to the f dot normalize. Dimension equals to 1, detach CPU and dot numpy. It will normalize and it will provide you the embedding value for whatever you have tried to query. Let's say if you queried, if you try to encode your query, then it would go ahead and it would create the inputs for that query text only. If you give image, it will create the inputs for the image only, and then for that it will create the embedding. I hope you understood this point, right? So this is how it's happening. The whole backbone here is your model, right? So model, whatever the model is being used here, I hope you already know mini CPM version 2.0 is being used here, which is a fine-tuned version of mini CPM and Siglip 400 itself, right? So that is being used here. It will be able to provide you the output, and this is how it is going to happen, right? So once this is a one function only written here, now the time come, right? What we will do, we'll be loading the VIS-RAG model itself, which is called retriever. So we have already initialized transformers, auto model, and auto encoder. You already know this is one module which is being used to kind of download, kind of initialize any particular model itself from the Hugging Face, or right. So auto, we are just giving the name of the model. The name of the model is somewhere VIS-RAG RET, which is from OpenBMB, right? In the last video already I have defined and showed you the model in the Hugging Face, how you can use it and everything, right? So we have just given the name, and from using the auto tokenizer dot pretend, I'm giving the model name part here, and trust mode I'm making as a true, and just trying to run it using T4, right? So from pretend model itself, I'm giving the path, torch, and I'm just creating model.evaluate. So when you click on it, it will take some time. It will download that particular model on your local, and it will show you this kind of architecture. Guys, I would suggest please go ahead and look into the architecture of this particular model, right? This is kind of giving you a good amount of knowledge itself. It's nothing, right? If you go for any particular model, how this is going to be used, it is just trying to use your neural network only, right? If you see the blocks are given here, on each blocks you have the different attention layers, normalization layers, right? K normalization, attention, like attention, you know, right? Already if you know attention, then how attention is being used. So please don't go on that much deep. If you know, that's okay, but if you don't know, that is also fine. You can directly use this model. You do not need to write code from the scratch to know these things, right? You just need to write this code, and automatically everything would be installed on your this notebook itself, and you can go ahead and test it out, right? If you want to dig it deeper, then in that case you have to start from transformers. You have to go check everything, like what is attention, what is positional encoding, what is decoders, what is encoders, everything you need to look into that. But yeah, if you want to dig it deeper. Otherwise, knowing this concept, how to use it, why it is being used, what is the use case of it, this should be clear, and that's all, right? So now let's talk about preparing the input and and that particular test data. What I did, this is a very simple use case. What I did, I'm just using two images, right? These images are already given by the OpenBMB. So this is one image, which is an image of a cat. It's very, and this is a image of a dog, right? So what I'm trying to do, I have just written this one using PIL itself. I'm just reading out this image using byte.io, right? And from this URL, I have just read out it and I've converted it into the RGB itself, right? This is my first image and this is my second image. I have two images on my passage dictionary, right? And it is here. And I have this query. This query is, what does a dog look like? Represent, and this instruction is something, represent this query for a retrieving relevant document. So do you know what is going to happen? If you have this data is containing the image of a cat and image of a dog. My question is, what does a dog look like, right? So now this question, actually I'm asking for the dog. So my retriever should retrieve me the image of the dog, not the image of the cat. And literally I'm saying this thing, that this model is capable of understanding the difference between the cat and the dog, and it is able to tell me like, okay, this is the dog image. You know, the difference between the cat and dog is very, like, for a model, for a human being it's very like common, but for model also it's very common now, right? So you can see the power of this model itself. It can able to tell you like, okay, this is the image of the dog, and it will retrieve the image of the dog. And that retrieval should be, if you click on this, it will just download all the all this data, right? And it will store on your store on your local itself, right? So that is what, right? Now this is the time. I'm just encoding my query. I'm just encoding my passage. What does it mean, passage? Passage means I have two images and both I am encoding, and query I have having that query, I'm encoding that also. So use the text would be encoded, this text would be encoded, this image would be encoded, and now both are being encoded. What I'm trying to do, I'm just writing a very simple line of code, that is embed query and embed doc.t transpose of it. I'm just trying to check the similarity between these two. And what I did, whatever the score I got, it would be direct multiplication, would be able to get it, and it will give me the score dot to list. So if I run this, I'm getting this particular score, if you see. So you are able to see that, right? The first value is for cat. If you see here, the first value was cat, the second value was dog. So if you see, the similarity score is high for the dog. So it will retrieve me that particular image of the dog, right? This image of the dog. As my question was somewhere containing this dog, right? So that's why it's returning me that dogs, right? And now this is still here. It was a retrieval step. Now we have the generation step. Generation is nothing. They are already there. This VIS-RAG is very good model actually. They are giving you the options to kind of concatenate your retrieved images. They can do the concatenation, they can do the weightage concatenation as well as they can do the one by one, like each of images they will take and they will give it to the model itself. Like a different kind of generation power is also given to the models here, right? So what they did, they have provided the mini CPM version 2.2.6, right? So for that 2.6 is capable of taking the multiple images as an input and give you the output itself. That's a generation part. So I'm initializing and downloading that model. So from the OpenBMB itself, mini CPM version 2.2, 2.6 I have downloaded here. So let me tell you about the generation code as well. It's a very straightforward, right? So whatever the retrieved image you got from the retrieval itself, when you query, right, you can directly give that particular image here to that particular model. So model.chat will be writing, and then image equals to image, whatever is retrieved from that context. Message equals to message, context would be none, and tokenizer is tokenizer. Sampling equals to true, and temperature I'm making as 0.7. So when you run it, you will be able to get the response and the context, both of them from here itself, right? So this is how mini CPM 2.0 is working for the generation. And this is how the retrieval is happening, right? This is how the similarity score is being calculated. So it's a basic code which is given by the author to run on this particular uh, Google Colab itself. So I have given you a kind of overview of this particular notebook, and there would be actually in the research paper itself, maybe it is in progress somewhere, right? So once this whole model is available and the pipeline is available, right, I'll try to make a kind of a Streamlit app which I have made for a coal pali, a same kind of app I'll make, and I'll deploy it somewhere, and I'll show you like how this VIS-RAG is performing with doing the comparison with the coal pali itself, right? So but I'll share link of this notebook in the description itself. You guys can go ahead and just try to do some experiment, right? We have already given you the link of VIS-RAG GitHub repo and the Hugging Face repo itself. So please go ahead and just try out that, guys. These are very awesome tool coming up right now, right in the multimodal phase. So yeah, that's it, right? That's it for this particular video. And I'm going to upload one more video on the VIS-RAG using the Streamlit app itself. So thank you so much for watching this particular video. Please do subscribe to our YouTube channel and hit the like button if you like this particular video. Thank you.